Hey guys, my name is Dagmaris and today I will be partnering up with Emily Velasquez. As you can see, we will be talking about the sliding filament theory. It is the explanations of how muscles contract to produce force. So I decided to try a muscle so you can see a little bit what it is or how it looks. And we will be talking in details about the steps.
Okay, in first step we have ACH is released. We have the muscle fiber right here and the motor neuron, and the motor neuron has vesicles that inside has the ACH that is released of the motor neuron and diffuses across the synaptic cleft. We have here the receptors, and these are the ACH. These are released and they travel to the synaptic cleft. In step 2, we have ACH binding and the beginning of action potential. ACH binds to its receptors on the muscle floor, generating action potential. We have here the ACH in the motor neuron. Then we have the muscle floor. We have ACH traveling in the synaptic cleft, the receptors where ACH is gonna be binding, how the way that we see here. Then we have the ions, these ones. In step 3, we have calcium release. The action potential stimulates the sarcoplasmic reticulum to release calcium. Here we have the muscle floor, the sarcoplasmic reticulum, and we have calcium here. These dots in red are the calcium. Action potential, that is excitement. Yay! In step 4, we have calcium freeze acting. Okay, here the calcium is used to remove the barrier, tropomyosin, from the myosin binding sites on actin. Here we have the calcium that is going to bind to actin to freeze the sarcomere.
Now, step number 5. It happens when the myosin uses ATP or energy to bind to actin, forming a cross bridge. As you can see, here is the calcium and how myosin is being created. Afterwards, the cross bridge will be formed. Step number 6. Described as the power stroke. Here we can see how a muscle contracts. It happens when the actin is pulled along the myosin toward the center of the sarcomere until the actin and myosin filaments are completely overlapped. The power stroke happens when the sarcomere is shortened and the contraction is complete. Here you can see the cross bridge and how the myosin is getting toward the center of the sarcomere. There is the thick filament tropomyosin, actin molecules, troponin, and thin filament. Step number 7. In this step, myosin uses another ATP or energy to unbind from actin or separate from actin. In other words, remove cross bridges. Here you can see the myosin and the cross bridges and how the ATP or energy is getting separated. It also can be called as the breaking connection. And last but not least, step number 8. Calcium returns to the sarcoplasmic reticulum to place the barrier back to the myosin binding. It means that actin is arresting or blocked. Here you can see the myosin, that are the blue dots, and the cross bridge and how it's separated, as I said in the step before. Troponin or tropomyosin complex slides are back into position where it blocks myosin binding sites of actin. Thank you very much for your attention.